Not yet, but I think it will come. Okay.
Okay.
I can see your screen.
Okay. Hello again and welcome to webinar 3, Refrigerant Design Selection and Verification. I am Nichakorn, will briefly introduce ProREFD software, and Siriporn, my colleague, will demonstrate some problem for more understanding. All right, let's begin with what is ProREFD. PSE4Speed has developed a software called ProREFD, which includes all of chemical properties, model calculations, simulation options, and selection method for refrigerant. You can search, design, simulate, analyze, and predict the refrigerant properties and design through ProREFD. ProREFD is the multifunctional toolbox containing 6 functions, which are the first one, modeling toolbox, is tool for solving and evaluating the refrigerant model with data-based modeling technique. The second one, database manager, is data source of pure property, including chemical property, VLE data, and aseotropic data. The third one, property estimation pure, is the estimation for pure compound property. Next is property estimation for organic system, is the estimation for organic system property. Next one is refrigerant selection, is a tool for selecting the considerable single or mixture refrigerant based on characteristic design. And the last one is refrigerant cycle simulation. It's a tool for simulating and analyzing the refrigerant model with thermodynamic modeling technique. Okay, the tool with tape will be presented and demonstrated. First, we would like to introduce Database Manager. Database Manager is a toolbox for searching the properties of refrigerant compounds, contains an extensive database which has different types of data. The search and retrieval provide a simple way of compound selection. This is the main interface of Database Manager. There are 4 main parts, which are: first is pure property search, as the function to search chemical property, correlation equation, and others. 2 types of search are available, which are basic search and advanced search. The second one, VLE search, describes the distribution of chemical species between the vapor phase and liquid phase. The next one is Aseotropic Search, describes an aseotropic of a binary mixture, indicate a point at fixed pressure or temperature, where the liquid phase and vapor phase has the same composition. And the last one is user database. You can input your own data for simulation and analysis. To search in ProREFD, there are many different ways. For example, give compound name, CAS number, molecular formula, or extra designation. Okay, now let's go through each part. Start with pure property search. The interface of pure property search is shown. First, we will show the basic search. Start the search in the search area and see the result in the table below. After select the compound to see its property, the property will be shown. There are 4 types of property available in database. The first one is refrigerant property. The important property for refrigerant simulation will be shown here. Next one is primary property. The basic chemical property with molecular structure will be shown. Next is temperature-dependent property, the experimental property which depends on temperature representing in equation forms. And the last one is estimation properties, the estimation properties which depends on temperature representing in equation forms. And next is the advanced search. Here is the interface of advanced search. We will give specific property parameter in the search area and see the result in the table below. Okay, now Siriporn is going to demonstrate basic search and advanced search using these problems.
Okay. My name is Siriporn Jalernsuk. Today I will demonstrate how to solve problem by using ProREFD software. Let me share my screen.
Okay.
Okay. Let's start with the problem at the database manager section at the basic search to find the pure property of data fluoroethane. Okay, so now we'll open the problem. Open the software. Okay. Here is the interface of ProREFD software. First of all, I will start with database selection to select the database. And then I click select. And then I select database manager and go through the pure property search tab with the basic search here. Then start the search by input name, data fluoroethane, and click search. Then click the compound and click view properties. Then our estimate and experimental properties of data fluoroethane are presented in 4 tabs, which are refrigerant properties, include the properties which is normally used for refrigerant system. And tab 2, primary properties, include the basic properties of compound. And you can click Run PL here. So the software will automatically go to pure property estimation. This function is used for estimate the pure component by using the new model, which is developed for predict the small molecule like a refrigerant. The main interface is separated into 3 parts, which are properties interface. You can find the predict properties here, and there are many different models that you can choose. Moreover, there is a refrigerant tab here, which will show the needed properties for refrigerant system calculation. And the right-hand side is drawing interface, and the top is the shortcut toolbar. For more detail of this function, you can watch back at webinar 2 on our YouTube channel. So I will close it now. And go to the next tab, which is temperature dependent properties. Include experimental temperature correlation. You can give the temperature value in equation, then calculate any properties related to the input temperature. And the last tab, estimation properties, is similar to temperature dependent property, but presented the estimate temperature correlation. Okay, and this is for the pure properties. And go to the next question. In the advanced search, to search for compound with boiling temperature within 200 to 250, then reduce the search space by giving values for critical pressure less than 50 bar. Then I will continue with the software and go to the advanced search here. Then I will select the first property, which is boiling temperature between 200 and 250. And then click search. Then the amount of the compound with the boiling temperature between 200 to 250 Kelvin is 76. Okay, then I will select the second compound, which is critical pressure less than 50 bar, and click search again. And now you can see that the amount of compound reduced to 17. And next, I will click on the compound that I interest and click view properties. Then the pure properties are shown similar to the previous case. Okay, so I will close it. And this is for the pure property search. Okay, I will stop it now.
Okay, I will continue share my screen. Okay, next is VLE search. Okay, start the search by input the compound name in the left box. ProREFD will automatically find its binary pair, so you can select its binary pair in the right box, then see the result in the table below. In case if the binary compound has azeotrope, the word file will be shown. Okay, The last one is Aseotropic Search. The search is very similar to VLE search. Start the search by input the compound name in the left box. ProREFD will automatically find its binary pair, so you can select its binary pair in the right box. Okay, then see the result in the table below. Okay, and again, Siriporn is going to demonstrate VLE search and Aseotropic search using these problems.
Okay. I will open the problem. The next problem for the VLE search. To search for VLE data for binary mixture of tetrafluoroethane and propane. Okay, I will continue on the software. Go to the VLE search here and start the search by input the name. Click search. Then all compound that has the binary data with tetrafluoroethane will present in the right side. Select another compound, which is propane, according to the problem. And you can see that if these two compounds have azeotropic, the word found is presented, and you can click show azeotrope data for a shortcut to the azeotrope data in the next step. And if there is no azeotrope data for this system, the word not found will be shown instead. Then I will click on the data set that I interest and click show VLE. The data information is presented on the top. The VLE experimental data tab will give the experimental data for the corresponding binary data set. And to see VLE plot, click here. And there are three types of plots, which are XY plot, PXY plot, and TXY plot. In this problem, I will select XY plot and then click update plot. The corresponding plot will be shown. The blue line is the baseline, and the measure data points are given at the dot. Moreover, you can click previous data or next data to see other data set of this binary compound. Okay, and this is for the VLE search. And for the next problem, to search for azeotropic data for binary mixture, then I will continue on the software and I will click show azeotrope here. Then all azeotropic data set of tetrafluoroethane and propane available in this data set will be shown in this table. Okay, and this is for the azeotrope search. So I will stop sharing.
Okay, and I will continue my part again. Next is property estimation for organic systems. Property estimation for organic system is a toolbox that provides the property results from organic mixture and also estimate the property of mixture. This is the main interface of property estimation for organic system. There are three main steps in property estimation for organic system. The first one is compound selection. Here you need to select the compound. Next is organic system configuration. The temperature, pressure, and composition of mixture are given here. The last one, the last one is property prediction. See the property prediction in this step. There are two types of property, which are mixture property like bubble point temperature, dew point pressure, and another is plot configuration, where you can see the plot like enthalpy, VLE. Here is the example result from property estimation for organic systems. Okay, Siriporn is going to demonstrate property estimation using these problems.
For the next problem at the property estimation organic system, to estimate the VLE phase diagram and bubble point temperature of tetrafluoroethane and propane with mass flow rate of 1 kg per hour, the operating condition temperature 273.15 Kelvin, pressure 1 atm, and thermodynamic model Jalernsuk with mixing rule parameter 0.17. So I will continue on the software. And I will open the property estimation for organic system. And there are 3 steps that user have to follow here. Step 1, compound selection to select the 2 compounds of binary mixture. Step 2, organic system configuration to specify the conditions. Step 3, property prediction to select the properties to calculate real phase diagram. So I will click step 1 and input the name. Click the name and click add here. Or you can click view to see more detail of the compound. Okay, so we exit and input the second compound, which is propane. And click add again, then click OK. And next, I will go to the step 2 to give the operating condition and mass flow rate of each compound. According to the problem, temperature need to change to 273 Kelvin, pressure 1 atm, and mass flow rate of 2 compounds is 1 kilogram per hour. And now the unit is incorrect, so I go to the unit configuration and change the mass to kilogram. Okay, and then click OK. And then I will go to the step 3. The mixture property is presented on the left side, the plot function in the middle, and the search database in the box below is presented the condition which has the experimental data in the ProREFD software. And then I will click on the compound at the organic component list, and then click on the bubble point temperature according to the problem, and click search database here. And to see if this binary mixture has experimental data for both isothermal and isobaric system, user can select the temperature or pressure to compare with the estimate data. Now I will select this temperature, okay, and go to the plot configuration and select the real phase diagram as the rectangular plotting type, and set x-axis with the data flow ethane liquid and y-axis as a data flow ethane vapor. And in the value configuration is presented the operating condition to do the estimate. User can adjust the temperature or pressure in point if the only one curve is selected, or in range if with step if the third axis is selected. Now I will adjust the decimal, right? And then I will click property model to change thermodynamic property, and click this bottom and select the EOS model as a Jalernsuk with mixing rule, and change the mixing rule to 0.17 according to the problem. And then click OK. And for the enthalpy model, I will click default to set enthalpy model as the default value, and click OK. And then click calculate here. Okay, so the software will calculate the bubble point temperature to 226.826 Kelvin, and the real phase diagram calculate as the data point here. Okay, so I will close now and click the line here. The XY plot is presented. There is an aseotrope with this binary data at this operating condition. So this plot can use to design distillation columns. Moreover, user can compare the estimate plot data with experimental data by click search experimental data. The experimental data is plotted at green dot here. Okay, and this is for the property prediction for organic compound. Okay, so I will close it. Stop now.
Okay, I will continue my part. Next is refrigerant cycle simulation. The simulation and optimization are functions that allow user to perform simulation process and enable to import external information by using equations-based simulation concept. This is the main interface of refrigerant cycle simulation. There are 5 main parts, which are: the first one is refrigerant specification. Here you can give the refrigerant type, compound, and its fraction. The second one, operating system specification. In this tab, you need to input the specification, for example, condenser pressure, evaporator temperature. Next is simulation results. After finish giving the operating condition and run the simulation, the results will be shown. Sensitivity analysis tab. Here you can see the effect of parameter to perform the refrigerant cycle. And the last one, thermodynamic diagrams. You can see the thermodynamic diagram like pH, TS diagram. The refrigerant cycle simulation can generate 3 main results, which are: the first one, refrigerant simulation, using the first 3 tabs. Okay, next is sensitivity analysis, using the first 3 tabs with sensitivity analysis tab, the 4th one. And the last one is thermodynamic diagram. The simulation is not needed. You can directly generate thermodynamic diagram. Otherwise, if you want to see cycle simulation in the diagram, you need to run the simulation. Okay, first, let's see how to do the refrigerant simulation. Start with it, select refrigerant type. There are 5 types available. Then give the compound and composition. The selected compound will be shown in the basic property. In case, the mixture property will be shown if the mixed refrigerant type is selected. After that, give operating condition and make sure that all consistency rules are verified. These are very important. Okay, and after run the simulation, ProREFD will automatically calculate using the input in operating condition and give the result as performance of cycle and result in each stage, which are temperature, pressure, enthalpy, entropy, and vapor fraction. Okay, now Siriporn is going to demonstrate refrigerant cycle simulation using these problems.
Okay. For the problem in the refrigerant cycle simulation section, to find COP of a single cycle process with data follow ethane with the operating condition below. Okay, so I will open the software. Open the refrigeration cycle simulation. Go to the refrigerant specification tabs, and I will click single refrigerant according to the problem and search the name, which is data follow ethane, and click search. Then click select. Then the selected compound is shown. The figure of the compound, compound name, and molecular formula are given. Also, boiling temperature, critical temperature, and critical pressure are shown. Then go to the next tab, operating system specification. To input the operating condition data by following a problem, you can see that some operating condition already has the default value, which are the same with the problem. Okay, then I will go to the condenser here. Either pressure or temperature and cooling temperature need to specify. From the problem, the condenser pressure is set to 50 bar, and the condenser temperature will automatically calculate. The cooling temperature is 298 Kelvin. The evaporator pressure is set to 3.5 bar, and at the same, the evaporator temperature will automatically calculate. Okay, and we need to make sure that all consistency rules are accepted. If all rules are accepted, the green tick will present like this. Then you can click run simulation. So the software will calculate the value based on the input parameter and then automatically automatically go to Simulation tab. The temperature, pressure, entropy, and vapor fraction in each state is presented, and the COP, compressor work consumption, evaporator, and condenser heat duty are also presented here. Okay, then I will go through the previous tab. In case user want to change the temperature of condenser or temperature of evaporator, you can pick this and you can change the number. For example, I will change to 377 Kelvin. The evaporator as well, you can pick this and can change the number. And after you change it, you need to make sure that all consistency rules are accepted, and then you click Run Simulation again and click OK. Okay, then the simulation result is shown here. Moreover, you can switch the unit from SI unit to English unit by click this, and you can export to Excel file by click this button. Okay, so this is the Excel file. Okay, so I close it. And this is for the simulation results. So I will stop it now.
Okay, next is thermodynamic diagram. As we say, thermodynamic diagram doesn't need a simulation result, but in this presentation, you will show thermodynamic diagram using simulation result that Siriporn has recently demonstrated. So you can see the cycle simulation in the diagram. Okay, after finished simulation, then go to thermodynamic diagram tab. On the top, you can adjust the temperature and pressure range and select the plot. The thermodynamic data and plot are shown below. You can see that the cycle simulation in thermodynamic diagram here. Okay. Next one is sensitivity analysis. Okay, as we said again, the simulation is needed in sensitivity analysis. So after finish the simulation, go to sensitivity analysis tab. Two tabs of parameters are available, which are compound property such as boiling temperature, and another is operating condition such as condenser pressure. Then give sensitivity analysis range and see the result as response variable and response variable difference. Okay, and now Siriporn is going to demonstrate thermodynamic diagram.
Okay, the next problem. To generate the thermodynamic diagram or pH diagram of tetrafluoroethane with the same operating condition. Okay, so I will open the software and go to the thermodynamic diagram, and there are 5 plots available, which are PV, PS, TS, pH, and TH. I will start the pH diagram, and you can see that the range of the temperature and pressure that you can adjust them. Then you can click calculate. After calculation is finished, the word calculate data is ready to be plotted is presented. Then click plot here. So the thermodynamic is presented. Also the cycle of operating condition is plotted in the diagram. And this diagram can use for performance calculation of a refrigerating machine and others. And as the same, you can export to an Excel file by click this button. Okay, and this is for the thermodynamic diagram. So I will stop now.
Oh, okay. Now is the last tool of refrigerant selection. Refrigerant selection is the function to select a refrigerant for a particular application based on user's requirement. The concept of this function is to find alternative refrigerant which has lower cost, get higher COP, and also has lower global warming potential or GWP. In this function, we'll list all possible refrigerant components that can be used in the alternative. User can design the interested refrigerant. Okay, this is the main interface of refrigerant selection. There are two functions in refrigerant selection. The first one is target selection. Here you can select refrigerant type and compounds. And the second one is refrigerant cycle simulation, is to give the operating condition for this selection. Okay, start by set the refrigerant target and operating condition. The results will be shown in the blue box, which is set as target results. Then find the alternative compound and see the result in the box below. The alternative will be use the same operating condition with the reference case. Okay, let's see the problem. Let's see this problem. The property of commercial refrigerant R143A, the GWP is quite high and better to reduce. Now Siriporn is going to demonstrate how to find the alternative single refrigerant. Here, the boiling temperature of alternative should close as target as possible.
Okay. Next problem, at the refrigerant selection section, to find alternative single refrigerant for difluoroethane, okay, with the operating condition below. So I will go to the software and open the refrigerant selection. Go to the target selection and click the single refrigerant according to the problem and search the chemical name, which is difluoroethane. Click search and click select. Then there are two sets of properties. Property set 1 is given as target that must be met, which are boiling temperature, critical pressure. However, user can adjust the condition range to see more alternative components and can also adjust the target property. And the tab 2, property set 2, are given as bounds that should be satisfied, but refrigerants may not be selected. Then I will go to the next step, refrigerant cycle specification. To give the operating condition according to the problem, you can see that there are some defaults, which values are the same with the problem, but some values are not. So I will change them. Condenser pressure need to change from 9 to 15 bar, and the evaporator pressure need to change to 3.5 bar, and then click run simulation. After calculation is finished, the result is shown in the blue block here. The calculate COP, condenser heat duty, evaporator heat duty, and compressor work. And in the middle here, there are 4 types of alternative, which are alternative single refrigerant, alternative binary mixture, alternative ternary mixture, and alternative quaternary mixture. I will select alternative single refrigerant from the problem and click Find Compounds. Okay. And the list of compounds which has boiling temperature in the range is presented. The basic property of compound of both experimental data and estimate data are also presented. Next, click on the interest compound. Okay. Or like a pentafluoroethane, and click run simulation. So the results are shown here, and you can compare with the target result. For example, the GWP of the alternative is 3,500, but the GWP of target is 4,800. So the GWP or global warming of the alternative is lower than the target one, and the COP of the alternative is higher than the target results here. And moreover, the heat duty of the evaporator, compressor work, and heat duty of condenser of the alternative is lower than the target result as well. So this alternative single refrigerant is better to replace the target one. And moreover, user can see the simulation result in each state by click go to simulation results. So the software will bring to the refrigerant specification function that user can click operating system specification and simulation result to view the detailed results for each state. The detail in this function I already described in the previous toolbox, so I will close it now. And moreover, you can click export to an Excel file by click this bottom. Okay, and this is for the alternative single refrigerant. So I will stop it now.
Okay, then try with another alternative by select refrigerant type and select alternative compound to see the result in the box below. Similar to the Siriporn's demonstration. So let's see again, 143 again. After replace with 125, boiling temperature is close to the reference one, but the GWP is lower. But critical temperature and pressure is not matched. Also, the COP is a bit low and GWP is a bit high. Okay, now Siriporn is going to demonstrate how to find the alternative ternary mixed refrigerant. Here, the boiling temperature of alternatives should exactly match with target. Either critical temperature or critical pressure should exactly match with target property. Also, there must be one refrigerant has lower than target property and one refrigerant has higher than target property.
Okay, the next question is to find alternative ternary mixture refrigerant. So I will click this tab. And this selection is use boiling temperature and second parameter as target property to calculate mole fraction of each component. The second parameter can be either critical temperature or critical pressure. In this example, I will choose critical temperature as and click at refrigerant mixture here. And the top box is presented the compound which has boiling temperature lower the target properties, and the middle box is presented the compound which have boiling temperature higher than the target. So I will select one compound from the top box, which is difluoromethane, and click add, and one from the middle box, which is tetafluoroethane, and click add, and another from either tops or bottom box. In this case, I will select the pentafluoroethane and click add, and then click OK. So the software will calculate the mole fraction and mass fraction based on a matched boiling temperature and critical temperature. Also, the mixture property is calculated here. Okay, then I will click Run Simulation. So this is the result that you can compare with the target above here. The COP of the alternative ternary is higher than the target result. And then I will click Add to Result List. Check it. You can see that the GWP of the alternative ternary mixture is lower than the target one, and when comparing with alternative single refrigerant, the GWP of alternative ternary is the lowest. So this alternative ternary refrigerant is the best to replace the target one. Okay, moreover, you can go to the simulation result to see the calculate data in more detail. Okay, so I close it now. And this is all for the alternative ternary mixture refrigerant. So I will stop it now. And this is all for our presentation.
Okay. Thank you, Nichakorn and Siriporn. It was very nice to see that everything was working, and I hope the participants can see that with the tool one can do this kind of calculations consistently, systematically, and correctly. That is most important. That it's not just to do the calculation, it has to be done consistently also. The thermodynamic rules need to be followed, and at the same time, the systematic approach is used so that everything is very fast, but also very accurate. So if you have any questions, we are happy to answer for you. Anybody has questions?
Some questions from general. Could you have issue with solid formation when working with new mixture in the refrigeration cycles?
I doubt there would be problems with solid formation because these are very light compounds. They will not crystallize unless you have a very wide temperature pressure range. So I would say that if solid formation is occurring, then either the conditions given were not very good or the selection of the refrigerant was not very good. So, but I don't think we had put any warning about solid formation. Maybe we should put a warning because we have the melting point data. So we can easily check whether the solid formation temperature has been passed or not. But I doubt very much that a good design would have solid formation. So except for if you want to go to, like for the Pfizer vaccine, I don't remember, it was like 20 degrees you have to go to, 20 K. If you want to go to so low a temperature, solid formation may be possible, but I doubt very much. Do you have any example of when solid could be formed? The one who asked the question. Alejandro Pedrosa. You can unmute yourself and ask if you want. The only thing I would say is that we have not come across a situation when question of solid formation would be used. Okay, I can see you are asking about hydrates, but I doubt hydrates would be considered as refrigerant in a refrigeration cycle. Hydrates are formed in the gas pipelines, but not in refrigeration cycles, I think. Another question, how does the substance configuration affect the properties in group contribution method? If I understand correctly, we just use the atom numbers to identify a chemical, because we have, for the search option, we have the atom number, we have the name, we have the smiles, we have the CAS number. There are different ways. So for example, if you give C2H6, all compounds with C2H6 will be shown. And you have to, as the user, would have to select which C2H6 you're interested in. But if you give the CAS number, then it is a unique molecular structure. And so that is the one. And if you give your correct CAS number, then it will be the unique molecule. And so there is no confusion about that. And we use the molecular structure, not the atom number, to predict the properties. So from the molecular structural information, we will find the groups, and then we will calculate the property. Okay, any other questions? No more? Okay, then I don't know if you have registered for the next seminar, webinar, which is on 25th of August. That is on chemical substitution. Actually, refrigerant selection is also a substitution problem, but we will not highlight the refrigerant selection or substitution. We will highlight other problems where the idea is that there is a chemical in some products. I think these days in every kind of product that one uses, from the time one wakes up in the morning to the time one goes to sleep, they're using some chemicals-based product. And the idea is that how to identify whether all the chemicals in that product are okay or not, or whether it will have some, it will make some negative effect, maybe on the health, maybe on the skin, maybe on the safety. So the idea is to identify the harmful chemicals and replace them before they cause any problem. So that is chemical substitution. It is a very, very common problem everywhere in the world. And but people do not talk that much about it. Although if one wants to register a product, they have to say which chemicals are being used and in what amount. So yes, so there will be more information, and hopefully some of you will attend. I can see one question here. Will 2-hexanol and 3-hexanol have different properties in contribution method? Yes, it will. They will. Because in this case, we do have second order groups and third order groups that will make distinction between 2-hexanol and 3-hexanol. When it does not make any difference is with isomers that are mirror images, cis-trans isomers. For those, we do not have extra groups, but for 2-hexanol and 3-hexanol, we do have. There is a question, is there a certificate provided after the webinar for those who attend and those who ask for it. So if you registered but didn't attend, of course, you don't get the certificate. But if you did register and you attended and you asked for it, the Thai office will give you the certificate. Okay, so you got the message also. Just ask the Thai office and they will give you. Okay, any other question? Okay, then we are finishing 5 minutes before. For those who are in Asia, you can go to sleep very soon. Thank you for staying awake. For those who are in USA, thank you for joining so early in the morning. And for those who are in Europe, it's normal time. Thank you for joining, and we hope to see you on the 25th of August. We have 2 guest speakers on 25th. And one other thing before I forget, for webinars 1 and 2, and also other selected seminar recorded videos, our YouTube channel link is provided on our website. You can go from there and download the files if you want. I mean the PowerPoint files, and also view the the recorded videos. We also plan to put in the videos on the manual, step by step, how to solve and use the software. Okay, so with that, thank you, and see you on 25th. And the Thai office, thank you for your organization.
Thank you.
Bye-bye.
Bye bye.